Assalamu alaikum students. I welcome you again to this third lecture, which is on differential equations solvable for P. We have previously delivered two lectures on this. Second one was how to solve the differential equations involving P. Now today we will be taking some miscellaneous forms. It is lecture number 3rd. In miscellaneous forms we will discuss first miscellaneous form where such equations are solvable for P, solvable for Y, then solvable for X. By solvable for Y I will discuss first. Equations, miscellaneous case first. This is first case where I want to discuss such equations solvable for Y. By solvable for Y we mean that when we are in a position to write Y explicitly on one side and on other side Y does not get involved. Or more precisely we can say such equations are linear equations in Y, when we can easily solve them for Y on one side and the right side will be involving X and P. Now let us see how we proceed in this case. I will just give you some basics on this differential equation. Now if you go to lecture number 1, previously lecture number 1, the differential equation that we considered there, which involves P, where we put dy by dx as P and it involved X and Y. So we write, consider the differential equation of the form, consider differential equation f x y p is equal to 0. You know now which equation this is. You can refer for this for your reference. I will say it is lecture number 1 on this equation is solvable for P, where I put dy by dx is equal to P. That equation you can name as equation this f of x y p equal to 0, because that equation only involves x, y variable and P, where we put dy by dx is equal to P. Now if this equation is solvable for Y, let us assume equation number 1 is solvable for Y. When it is solvable for Y means you can write Y on explicitly on one side and X and P on other side. Say we can have Y is equal to some function of this form, say psi of xp. This will be this function. Y exists on other side and X and P on another side. What you do is then we differentiate. These are also the steps of how we solve the such equations which can be solved for Y on other side, X and P on another side. These are the steps for solving such questions. We differentiate this. Let us differentiate this. Differentiate with respect to X now. When you differentiate with respect to X, what is this? You get this dy by dx is equal to, this is with respect to X, say it is partial of psi with respect to X, then P is also the function of X. You can write del psi by del P into dP by dx, because P is a function of X. Then this is your P is equal to d psi by dx plus del psi by del P into dP by dx. That means you get now some function of this form. This will be function involving P del psi by del P by del X, and this we write, let this function be we assume that this function is let us assume that this function is of this form. This will be some function now, say g involving x p, say dp by d psi, dp by dx is equal to 0. The function y will go here. It will not now involve y. Now we solve this. Solve by some method, say by variable separable method or some other method. You will get a solution. Solution will be of this type. Say it is some function g of x p c is equal to 0. Let this be equation number 3rd. Then what we do is we eliminate c between second, not c, sorry, p. We eliminate, it is p. We eliminate p between second equation and 3rd. That is, from this you can find out p and use this p in second equation. First was the full differential equation involving x, y and p. Second, we write y is equal to some function of x and p. We use p there. We get p from here, use in second, eliminate p. Now in some cases it is not possible to eliminate the p. That is a very important question. In certain cases you find it very difficult to eliminate p. Here you may get p in some radicals, some powers, some fractional powers, where it is very difficult to eliminate p. It will consume your time to eliminate p. What you do at this time? You remember, if it is, I will write here. However, if it is not possible to eliminate p between second and 3rd, if you find it difficult to eliminate p, first is to eliminate p, find p here, use it second, or there, use it here, so that p gets eliminated. If it is not possible to eliminate p between second and 3rd, then what we do is we express second and 3rd in terms of x and y. X is equal to something, y is what something, x and y express in terms of x and y involving p and c. We write x is equal to something involving p and c. You write y, this involving p and c. That will be the solution. In this case we say this is the solution. Means second equation, that was your equation, x is equal to y is equal to xp, isn't that? You write that y in terms of p and c. Here you write x in terms of p and c. So two equations will form the solution in case it is difficult to eliminate p. This is the method how we do such questions when we have the differential equations solvable for y. This is miscellaneous part, miscellaneous condition, this miscellaneous form first, then we will treat equations which are solvable for x, then we will treat equations where one variable is missing, then gradually we are coming closer to Claurit's form. Actually Claurit's form is of this type where you have y is equal to px plus some function of p. That means also there we have equation solvable for y. So this is a little bit also, this gives us a little clue about Claurit's form, which will be very simple now solve. Let me have some applications. I will take some applications so that let us have some applications. Applications of, these are the equations which will be now solvable for y, where you find it easy that equation is all solvable for y. Let me have some applications on this. I will take from different We have collected these applications from different books. Let us have a simple application here. It is solve the differential equation. Let us solve. It is y plus px minus x4 p square equal to 0. Y plus px minus x4 p square is equal to 0. This is the differential equation. We want to solve this differential equation. You see here, it is obvious from this equation you find y linear. That is, this differential equation can be written as y is equal to function of x and p only. Y is equal to function of x and p only. So we say mathematically it is solvable for what? It is solvable for y. We write it y is equal to minus px plus x4 p square. Okay. Now differentiate with respect to x. As I said in the previous this dy by dx will be with respect to x. P is also a function. P is function of both x and y. Now you write here product rule. Derivative of x with respect to x is 1, then p, then plus x as it is. Derivative of p is will be dp by dx. Okay, this is this. Here also product rule. This will be 4x cube, then p square, then plus x4. It is 2p. Derivative of p will be dp by dx because p is a function of x. Do you follow me? Okay. This dy by dx is p. This is your p. It is your minus p. This is minus x dp by dx, and this will be plus 4x cube p square plus 2p x4 dp by dx. Let us see what happens. The terms which are this free from dp by dx, I will collect them. I can write it as 0 is equal to this go with this minus 2p. This is minus x dp by dx plus 4 x cube p square, then plus 2p x4 dp by dx. Let me connect this with this. This is 0 is equal to you can take common here. You can take dp by dx. It is your 2p x4 minus x. Then here you can take plus p common. Take 2p common. This is 2p x cube. 2p is common, minus 1. Let us see. This is 0 is equal to dp by dx, x common. It is 2p x cube minus 1, 2p x cube minus 1. It is plus 2p, again 2p x cube minus 1. You see what happens. Well, let me rub this. I can take this now common from this. This is 2p x cube minus 1 into x dp by dx plus 2p is equal to 0. 2p is equal to 0. You see, you should reject this one. We rejecting 2p x cube minus 1 because it does not involve a derivative. Remember this. Even if you take p from here and then substitute in the given equation, that is known as a singular solution. That will be called singular solution. But here the factor which does not involve the derivative, it is this. You reject it here for the time being. You reject it. You take that factor which involves derivative. Remember this thing. The derivative involves this. We will take this factor equal to 0. We will write x dp by dx plus 2p is equal to 0. Remember this, we are not taking the p from this. Even if you take p from this, then substitute the value of p in the given equation. P will also get cancelled there, but that will be called a singular solution. For general solution, you should take the factor which involves derivative. Remember this, it involves derivative. I can write it variable separable, or this can be written as variable separable. X dp by dx is minus 2p. I can write it dp by p is equal to minus 2. This is 1 by x dx. This is 1 by x dx. So variables got separated. Variable is separated. Let us see what happens here. Okay, let me integrate it on both sides. As you do, it is integral of 1 by p dp. I can write it plus twice integral of 1 by x dx. I will add c on this side. It is one and the same. This is log p. This is your plus twice log x is equal to, I can choose this log c. So this gives log p plus log of x square is equal to log c. This gives me px square is equal to c. Oh yes, this gives p is equal to c by x square. Here you could easily find out p. Now what you have to do, you have to use the value of p in the given equation. Use value of p. Use value of p in given equation. What was that? What was that given equation? Let me see it again. I have to write that equation. What is that? Using value of p in the given equation, it was y minus y is equal to this was your equation. You use the value of p here, you will get the solution that will be free from p now. It is y is equal to minus times, what is your p? C by x square. It is c by x square into x plus x4 into c by x square whole square. Well, our solution is now complete here, because we could easily solve it for p. This is y is equal to, it is minus c by x plus c square. So you can write solution is y plus c by x is equal to c square. This is the solution of this differential equation. Let us write one more application so that you will have a drill on these questions. Let us have a question here. Suppose you are asked to solve, it is in different books this question, solve y is equal to 2px plus f of xp square. This is the question. Solve this. Okay, you observe on one side you have only function of x and p. You have only function of x and p. X involved, p involved, y is on other side. So you can write this differential equation is what? It is solvable for y. This is solvable for y. How you go? You will differentiate as usual. Let us differentiate this. Differentiate with respect to what? X. This is your dy by dx is equal to, this is 2 out. I can write derivative of x is 1, p as it is, then plus x, it is dp by dx. Okay, this is plus f dash xp square into derivative x1 p square plus x as it is 2px dp by dx. Let us see again. Derivative 2 out, derivative of x is 1, p plus x, p is dp by dx, f dash this, then p square as it is x 2p dp by dx. Let us see. Let us have it a solution. You can write, now this is your p, this is your p. You can write this p is equal to 2p plus 2x dp by dx. It is plus f dash xp square into it is p square, again 2px dp by dx. Let us have the factors now. This will be 0 is equal to 2p minus p, it is p plus 2x dp by dx. You can write it p square f dash xp square, then plus 2px f dash xp square dp by dx. Yes, this is dp by dx, this is dp by dx. I will connect it, taking here, this is 0 is equal to, from these two factors I will take what common, 2x dp by dx is out. Inside it is 1 plus 2x is out, it is p dp by dx into, now connect this and this. From this you can take p common, it is again 1 plus p f dash, it is out dp by dx here, it is f dash, sorry, this is out, 2x is out, dp by dx is out, it is p f dash xp square. Here also you look here, p is out, it is p f dash xp square. Well, you have got the same factor here. You could factorize it easily. Now what is this? Take this and this. This will be 0 is equal to 1 plus p f dash xp square into 2x dp by dx plus p. Now, as in previous question I told you, we rejected this, it does not involve derivative. Even if we get p from this, then that gives some singular solution. But what we take this factor equal to 0. This will help us in finding out the p derivative. We take this one, 2x dp by dx plus p is equal to 0. I think here it is easily variable separable form. This you can write, it is 2x dp by dx is equal to minus p. This gives you dp by p is equal to minus 2. I will write here twice, dp by p is equal to minus 1 by x dx. So variables got separated. It is an easy one here because you could separate the variables. This question is in almost all the books. You will find this question. That is why I have picked this particular question for you, so that you can solve it now. Integrate on both sides. This with respect to b. This is this separable. This is log p. This will be log p. This is minus log x. This is your c. You can write log of p square plus log x is equal to c. You can write it is log of what? P square x is equal to log c. Log is at your disposal. You can choose as c, log c. It is an arbitrary constant at your disposal. You have to choose any constant involving but c. Now this is p square x is equal to c. This gives p square is c by x. I can write now p is equal to root of c by x. This is p. Now you can easily eliminate p between the given equation and this. Now use this in given equation. What was that? Y is equal to 2px plus f of xp square. This was your equation. Y is equal to 2px plus f, given question. Now use here this is y is equal to 2x. The value of p is under root of c by x plus f of, this is your x, this is your square of this, it will be c by x. Now you can write it y is equal to 2x, it is root c by root x, this is plus f of c. So it is y is equal to, you can write it 2 root x root c plus f of c. So solution is, this is the solution. Your solution of the differential equation is y is equal to twice root cx plus f of c. This is the solution of this differential equation. When we could express it, y is equal to function of xp. Okay, so this is also the separable. Let us take one more application I would like to share with you, so that you will have a full concept how we solve such equations. Let me take one more application. I am taking one more application, sharing one more application here. Let us take a question here. Suppose it is solve. You have to solve. Let us solve. It is e raised to power p minus y is equal to p square minus 1. I have to solve this. Look, you find here y is in linear form. P is not in linear form, y is in linear form. I can go this way, taking log on both sides. This is p minus y is what? Log of p square minus 1. This you can write y is equal to p minus log of p square minus 1. Name this equation number 1. Y is p minus log of p square. I will write this equation here. Finally I will require this p minus log of p square minus 1. This is my equation number 1. I will write it here. I will use it later on. Okay, this is y. No problem. The right side has only p, not x. That does not make any difference, because we could write this function y explicitly linearly on one side and p terms and x terms on other side. Sometimes you write only y one side, other side is only p. It is only p. You can differentiate here again the same way. Differentiate with respect to x. Okay, this is dy by dx. This is here p derivative. It is p into dp by dx. Derivative of p will be dp by dx. Then minus log p, it is 1 by p square minus 1. Derivative, it is 2p into dp by dx. Okay, this is your p is equal to dp by dx minus 2p by p square minus 1 into dp by dx. You can take here p is equal to 1 minus 2p by p square minus 1 into dp by dx. On the other way, let us write this now. This you can write dx by dp is equal to 1 by p 1 minus 2p by p square minus 1. This is dx is equal to separable variable 1 by p minus 2 by p square minus 1 dp. So variable is got what? Separated. So you can integrate integral of 1 with respect to x, 1 by p dp minus twice 1 by p square minus 1 dp. It is x is equal to log p minus 2. Now how you differentiate this thing? You know this is a fundamental integral of dx by x square minus a square. What is this? It is 1 by 2a log of x minus a by x plus a. Fundamental formula. Use it here. Okay, this is 2. 1 by 2a is your 1 into log of p minus 1 by p plus 1. P is your variable here because we are integrating it with respect to p. P will be your variable. It is 1 square. It coincides with this. So you have x is equal to log p minus log of p minus 1 by p plus 1. What you do here, it is difficult to eliminate p. I deliberately took this question where you cannot eliminate p. It is difficult to eliminate p here, but x is in terms of p. Okay, what will be your solution? So you cannot eliminate p here directly, time consuming. You will write the solution of differential equation is, here you have to write some constant plus c. C is must. Solution of differential equation is, what is this? X is equal to log p minus log of p minus 1 by p plus 1 plus c, and y is equal to p minus log of p square minus 1. This is the solution of the differential equation. This is the solution of the given differential equation in terms of x and y, because we could not eliminate p. Okay. And these are some typical questions when we can express the y on one side. If we would like, we can have one more application on this. Let me have one more application so that you can do all the questions later on very easily. Follow. Okay, let us solve this question. It is y is equal to p tan p log of cos p. Here you also observe that this is the question where we could write y explicitly on one side. So there are different ways to get rid of any confusion. Sometimes y is function of xy, sometimes it is only function of p. In that way also we say the same method. It is solvable for y. Now we differentiate this. Differentiate with respect to y, with respect to x, sorry. It is dy by dx. Here product rule, derivative of p, dp by dx, tan p as it is, then plus p as it is. Derivative of tan is, okay, sec square p. Derivative of p is dp by dx, because p is a function of x. Then derivative of log 1 by cos p. Then derivative of cos p is minus sin p into dp by dx. Do you follow? It is simple differentiation. Let us write, this is your p as usual. Let me take dp by dx. Here we have dp by dx everywhere. I can write it this way. It is tan p. Then it is your p tan p sec square. It is p sec square p. Okay. This is your minus sin tan p. It is your dp by dx. It does not survive. So it is p is equal to p sec square p dp by dx. You can write it dx is pp goes, dx is sec square p dp. So variables got separated. You can write it integral of 1 dx, integral of sec square p dp plus c. Am I doing correctly? Dp by dx throughout common, tan p plus p sec square p minus sin by cos tan p. This goes cancelled. This p sec square p dp by dx. Okay, this is okay. Okay, this is this is your x. Sec square p, integral of sec square p is tan p. It is tan p plus c. So this you can write there. Here also in this case, if you find it difficult, you have x is equal to, here you can write in this case also, required solution is what? X is equal to tan p plus c, and given equation, what was that? Y is equal to p tan p plus, it was p, what was that? Given solution in this equation, what was given equation? I will have to write down the given equation. It was perhaps, what was this? It was, yes, p tan p plus log of cos p, and this is the solution. Y is equal to x tan p plus c, y is equal to p tan p log cos p, because it is difficult to eliminate, it is time consuming. Although you can write here p, p will be tan inverse x minus c, no doubt. Then you have to write tan pc, then you have to convert log of cos p in terms of c. If you write in this way, for simplicity, this is the solution. Then you have to write cos p in terms of sec square p, then use the value of tan p from this. But simple solution is this, x is equal to this, y is equal to this. So with this we have discussed with you in lecture number 3, the miscellaneous form, when differential equations are what? These are solvable for y, that is, we can express y explicitly on one side, and other side will be either a function of p or both x and p, how we solve such equations. And next time we will come with another 4th lecture. There we will discuss with you equation solvable for x, and then when x is missing, y is missing, and in between that we'll be sharing with you the solution of Claurit's differential equation. Very simple. Now thank you very much. I hope you will revise these lectures, then you will go to the next one. Thank you very much. Okay.